Okay, this is lesson 7.1, equivalent forms of exponential equations. Basically what we're going to be talking about is that we can, just like people can have different names, we can call them different things, so we can represent numbers in different ways too, depending on the situation. And the same is true of exponential functions. Exponential functions can be expressed in many different ways. Exponential functions can be expressed in different ways. Sometimes it is useful to express an exponential expression using a different base than the one that is given. So exponential functions can be expressed in different ways, like using a different base than the one that is given. So what we're going to be working with today is a bunch of change of base. We're going to change the base of the powers in exponential functions. And to do that, we will look at example 1. Example 1 asks us to express the following functions as powers with a base of 2. As a power with a base of 2. A is just the number 8. And we need to express this as a power of 2. Well, 8 is the third power of 2. What we mean by that is 8 is the same as 2 times 2 times 2, which is 2 to the power of 3. 8 is the third power of 2. B, 4 to the power of 3. We want to rewrite this as a base with a base of 2. Well, we can see here that 4 is simply 2 to the power of 2, and then we are still raising that to the power of 3. And we apply our power of a power law, which says that when we have a power to a power, we're simply going to multiply the exponents. This gives us 2 to the power of 6. That is the same as 4 to the power of 3 in terms where 2 is the base. Good. C is a little bit longer. I'm going to clear the board and come up to the top. C has the square root of 16 times the fifth root of 32 to the power of 3. How can we write that in terms of a power with a base of 2? Well, we're going to take each term separately. So there's some things we should remember about our power rules. So square root of 16. According to our properties of exponential functions, the square root of 16 is the same as 16 to the power of 1/2. The fifth root of 32 to the power of 3. I'm going to do that one in 2 steps. The fifth root of something is the same as 32 to the power of 1/5. And then we still have that whole thing to the power of 3. And like last example, the power of power rules tells us that 32 to the power of 1/5 to the power of 3, we just have to multiply the exponents. So this is going to end up being 32 to the power of 3/5. Well, I can now see I have 16 and I have a 32. I know that I can write those as powers of 2. 16 is 2 to the power of 4. And still to the power of a half. 32 is the 5th power of 2. Still to the power of 3 over 5. And now again, by the rule of exponents, I can just multiply my exponents together, which gives me 2, and then I have 4 times a half, which is 2, times 5 times 3 over 5. Well, that's simply 3. The final answer here, I can scroll up a little bit. In terms of 2, with powers with a base of 2, if I have a multiplication rule of powers here, I'm just adding my exponents. This is 2 to the power of 5. D. D asks us to take the number 12 and express it as a power with a base of 2. Now that's a little bit more challenging because it cannot be solved the same way that we solved A, B, or C. In order to express 12 as a power of 2, we have to solve this equation. 2 to the power of k equals 12. So the base of 2 to some exponent is going to equal 12. That's our goal here. We could use a guess and check situation, or from what we know about logarithms, we can express this as a logarithmic equation. So we're going to make both sides a log. So this tells us also that the log of 2 to the power of k is equal to the log of 12. And because of our rules of logarithms, I know that the log of 2 to the power of k is the same as k times the log of 2. My right side, that's funny, my right side stays the same here, log 12. And now all I have to do is solve for k by dividing both sides by the log of 2. And these logs are common logs with a base of 10, and our calculator can do this. So if k equals the log of 12 over the log of 2, then 12 can be expressed as 2. So we're just using this guy right here and subbing in what we know about k. 2 to the power of the log of 12 over the log of 2. And now we have expressed 12 as a power with a base of 2. In example 2, we'll be using our skills to solve an equation by changing the base. So here we have 4 to the power of x plus 5 is equal to 64 to the power of x. And so we want to find out the value of x in this equation. The first thing we're going to do is express the base on the right side as a power with base 4 so that it matches up with the base on the left side. So we can keep the left side the same, 4 to the power of x plus 5. And now we express 64 as a power with a base of 4. Now the hint to this is that I need to be able to see a pattern between the 4 and 64. Turns out that 4 times 4 is 16, and 16 times 4 is 64. So 64 is the same as 4 to the power of 3, and then I'm going to take that, and it's raised to the power of x yet. Well, I can simplify this right side using my power of power rules. This doesn't reduce to, it's simply 4 to the power of 3x. So now I have 4 to the power of 3x is equal to 4 to the power of x plus 5. Well, if the base is the same, then it must be true that x plus 5 is equal to 3x. Now I can use simple algebra. Subtract x from both sides. Get me 5 equal to 2x. And now I can divide both sides by 2. X is equal to 5 over 2. B. 4 to the power of 2 times x is equal to 8 to the power of x minus 3. And again, I want to solve for x, and I'm going to solve by changing the base. Now, I can't get directly from 4 to 8 using exponents. 4 times 4 is already 16. But I do see a pattern that I can use. Both of these numbers, 4 and 8, can be expressed as a power with the base of 2. So 4 is 2 squared, and 8 is 2 to the power of 3. We can simplify this with our power of powers rule. We're going to multiply our exponents. The left side becomes 2 to the power of 4x, and the right side becomes 2 to the power of 3x minus 9. I simply multiply the first term by both terms inside the second binomial here. Now I have 4x equals 3x minus 9. I can subtract 3x from both sides, which leaves me with x equals negative 9, and that is the solution. Okay, some key things we want to remember here is that exponential functions and expressions can be expressed in different ways simply by changing the base. Also, changing the base of one or more exponential expressions is a useful technique for solving exponential equations. And when in doubt, you can usually double check your work with the use of graphing technology like GSP or a calculator. Here's your homework for 7.1, page 368, numbers 1 through 9 and 15. Give them a try.